Hey guys. So today we covered some review stuff on identities and proofs, and I did actually miss one of the things I was supposed to cover with you guys, which was using double angle identities to simplify statements. So I'm going to do a quick little video on this, and but before you do that, maybe check on the website. You should see this posted now. Not sure if you can see it very well, but it covers most of the identities that we talked about and all the ones that you'll need to know for your test. So this sheet's what you're going to get on your test on Wednesday for the block A group, and then Wednesday for I think one of the color groups, and then the other one's on Thursday. So anyways, this is the sheet you'll use for your test. So I'm going to share my screen, and I'm going to go over a few questions dealing with our double angle identities questions here. So I'm going to turn my picture off here. Otherwise, you're going to be staring at my forehead. It's a huge forehead. Let's turn that off. There we go. Okay. So let's write down our first question, and we're going to simplify this once again using identities here. So hopefully I can do that. Right here. So simplify. Ooh, nice red. Simplify 12 sine 4x cos 4x. Now this question would probably be in sort of like the multiple choice section, where you'd be looking at various stems and trying to figure out which one matches it. And so if you look at your formula sheet, what you want to look for is a formula where you have this sort of sine cos side by side. And you can kind of see that in the addition identity for sine A plus B and sine A minus B. But notice in that formula, there's only one, there's two terms, like there's sine A cos B plus cos A sine B. And so this one's just a single statement here. So there must be something else on the table that kind of looks like that. And if you sort of scooch on your way down the bottom, you're going to find 2 sine A cos A, and that's equal to the double angle identity for sine 2A. So that's the one we're working with here. But you can notice the writing in purple is not quite that way. It looks a little bit different to me. So I'm going to write a let statement here. I'm going to say let A equal 4x. Okay, so wherever I see 4x, I'm just going to write A here. So it's going to be sine A cos A. So that's that taken care of. Now the problem is there's also this 2 in front. You see this 2 here, and I've got a 12 in front here. So I'm going to make a 2 appear in front of that, so it looks exactly like the identity. But what number times 2 is 12? Well, that would be 6. So it's really 6 multiplied by this thing in the brackets here. That would be the same thing as 12 sine A cos A, which would be the same as 12 sine 4x cos 4x. Okay, so what do I do with this thing in the brackets then? Well, sine 2A is equal to 2 sine A cos A. So I could still write this as 6 being multiplied by the sine of 2A. Now A was 4x though. So this would be 6 multiplied by sine, and this would be 2 times 4x. That's 8x. So that would be 8x then. So the statement here can be written as a single trig term by using the double angle identity for sine. So I'm going to give you 2 more questions, and I'd ask you to maybe to pause the video and see if you can solve them on your own. And if you can, great. Maybe check afterwards. But if you can't, then obviously watch the rest of the video here. So let's take 4 minus 8 cos squared 6x. That's one question, it's an example. And the second question we're going to say is 4 tan 3x all over 1 minus tan squared 3x. So once again, pause the video here and see if you can simplify these by using the double angle identities on the formula sheet. Okay, so take a second to do that. I'll just stop I'll pretend like I'm stopping. Press pause. Okay, welcome back. Okay, here we go. So we're taking a look at the first identity here. And if you look on the formula sheet, this looks really close or close enough, I think, to to cos 2a. So this looks a lot like cos 2a. Now, cos 2a, you'll notice, has three separate identities. So you don't need to memorize them, you got to recognize them. And so this looks a lot like the one that starts off starts off as, where are we here? With cos in it. So we have 2 cos squared a, right? Minus 1. So see if you can find that on your formula sheet. So it looks pretty similar to that. So what I'm going to do is try to arrange it, because right now it's a number minus the cos term. So I'm going to flip it and I'm going to factor out a -4. Okay, so let's see what happens here. So I'm going to factor out the -4. Okay, and now we've got brackets here. That would be 2 cos squared 6x minus 1. So factoring out the negative here. And once again, you don't have to write a let statement, but you could say let, let's say let b equal 6x. Okay, so wherever I see 6x, I'm going to write a b here. So this would be -4, 2 cos b minus 1. Now, b here would be -4. Now, 2 cos, let's see a square there. 2 cos squared b minus 1 is equal to cos 2b. And what was b? Well, b was 6x. So -4 cosine of 2 times 6 is 12x then. Okay. Okay, so let's try the next one here. Let's see what we think about this next one here. Okay, so this identity looks like it's got something to do with tans, I'm thinking. So if we go down to our double angle identity for tan, we see that that is, let me just change my color here, the tan of 2a is equal to, and that is going to be, tan of 2a, sorry, is 2 tan of angle A all over 1 minus tan squared of A. So you can see that this part here looks a lot like that part over there, except for, you know, middle there's like this, there's a 4 here, there's a 3x instead of an a here. So why not write a little let statement, say let a equal 3x. Okay, so I'm going to rewrite this then as, then let's factor a 2 out of the top part too. So 2 multiplied by 2 tan of a. That's all over 1 minus tan squared of a. So if you notice this part, I'm going to highlight this part here. So let's look at this part right here. So that part I'm highlighting in yellow is really identical to that. Like that's exactly the same thing, right? So why not keep the 2 out? Let's keep the 2 out for now. So say 2 multiplied by what that is. That's 2 times the tan of 2a. So that's 2 multiplied by tan of 2 times a. A is 3x, so 2 tan of 3 times 2 is 6x. Okay, so this statement on this side and this statement on this side are simplified statements, as is the one up here. And those are simplified statements using double angle identities. So I might do another little video in a second here, but just going to see if this one uploads properly for me. And so if you want to practice this, this would be page 340, question numbers 1 to, number 1, sorry. And letters A, I think if you can go A to K, you're pretty good with that. Okay, so it's going to stop that and hopefully record it.